Good morning. We will start the lecture today. So today is week 12, the November 23rd, so week 12. So week 12 is here. Okay. And we already finished the net and XNet. We also finished the VGG 16. And originally the lecture will talk about Google Net and RaceNet, but I will continue to talk about this one next time because I feel some basic thing I need to understand. So I will add 2 more lecture in the FTP site. So you can visit the FTP site and download this one, given in 0113 and 014. This is for undergraduate class. Okay, but I feel this graduate class probably I need to add this one. This I organize for entire deep learning. Okay, but for the graduate class, I teach based on the paper. But I feel probably I need to add more like the basic the deep learning thing for you. So today I will teach you before I teach you the ResNet next week or 2 weeks later. I would like to teach you how do you design the network and how do you adjust the parameter of the network. So you can visit the FTP site and download this one. And so the other thing is that after I include this week because I almost finished the computer vision things and machine learning because we already finished the PCA. So I will teach you LDA today. I only spend 1 hour. And next 2 hours, I will teach you deep learning. So the sense of after this week, okay, the first hour, I will teach you the computer vision. And the rest 2 hours, I'll teach you the deep learning. Okay, so I'll teach you the SVM. I'll teach you the VQ. Those things are related to the deep learning from the computer vision. But right now, many deep learning network do the classification and they based on the SVM, the kernel function, when it become activation function. And this for unsupervised learning for clustering. So I'll teach you those. But each time I only spend 1 hour for this one, and the rest 2 hours I will teach you deep learning. So the same after I teach you the fundamental design for the deep learning network, I will go back to teach you Google Net, the same, RaceNet, and UNet. I'll also teach you all of them. And also for the second assignment, okay, for the second assignment, originally is next week. Okay, but we will postpone one week. So I'll give you the second assignment on the week 14th. The exam probably will 1 week later, but I'm not sure. And next week, we will start to do the group project preparation. Okay, so probably 4 or 5 per student will be one group, and each group, okay, will find one paper. The paper can have a source code, it's fine. And the important thing is for the project, I will teach you how to do the PPT file, especially you guys are the graduate students. In Taiwan, we are not good at teaching you students about doing the Word, doing the report, doing the PPT。就台湾这方面蛮烂的哈。美国从小就开始学那个 Word 啊，学 Office 啊，但不是学 Office 啊，他们是学 Macintosh，因为 Macintosh 比较漂亮。但是他们这些工具，他们从小就学了。那根据我的经验，我学生经验还蛮烂的，就你们都不会。 Word 不大会做 ，PPT 不大会做，所以 so that I will teach you how to do that based on the project. Okay. I'll continue. And today we will return you the answer sheet of the midterm. So you can come here and then pick up your answer sheet. And if you have any question, you can go to the TA and to discuss with them. Okay. Any problem about the grade, you can discuss with them. And also during the hour, you can visit our lab, discuss with them. So I give you the answer today. We first of all, we talk about the answer for this one. Okay. And the average for the grade, as I remember, is about 80 something. But that's a good one. 90 is too high. 70 is too low. So 80, I think is good. Everybody. About the average of the grade is around 80. So that's good. So first one, for the camera model. Okay. And I ask you this one. So what's this is a XYZ, the world coordinate. And this is the camera 3D coordinate. And H will include the rotation and translation. Okay, so you write this one. I think the lecture already have this one. You just find this page and it'll give you the answer here. And for the second one, this is intrinsic parameters. Okay, so after we have a camera coordinate here, okay, and we have a 2D image coordinate. So A will be the intrinsic parameters. So the lecture here also has this one. So you should write the 3x3 matrix that include alpha, beta, gamma, and the principal point. Okay. So the second answer. So third one is what's the H? This one. Because it's 3D to 3D rotation translation, so it's the affine transform. So this answer will be affine transform. And for the A will be 3D project to the 2D. So the answer will be projection transform. Intrinsic parameters are projection transform. Actually, projection transform matrix. So that's for the answer. The second question is about camera calibration. The same. Our second exam I will do the same thing. I will ask you basically is what's the physical meaning, and most of the question will be related to your homework. So you do your homework. However, the exam or the question, most of them are related to the homework. So the same as this one. So for the camera calibration, so what is this term? It's exponential term or the sum of square difference term, this term. And this term, okay, we call Manhattan-Bus distance. Manhattan-Bus distance. If you don't have the half, the square root, if you don't have this one, it will look like Euclidean distance. But Euclidean distance has no covariance matrix. Manhattan-Bus distance has a covariance matrix in the denominator term. Also, there is square root here. Okay. So the distance measurement is kind of a similarity measure. Distance is equal to the inverse of a similarity measure. So this is a similarity measure. Okay. The second one is if our covariance matrix, this one, is equal to I, is the identity, is the meaning 1. Okay. So how can we solve this one? So we will do the maxima MAP. So this answer is for nonlinear. I told you that what's the nonlinear minimization. So the answer will be LM method. Okay. So closed form solution is a first order, is a linear first order solution. Pseudo inverse is the same, is the first order, and LM is a second order. So all the solution, actually all the for the optimization in our lecture only have 3 methods. Only 3 methods. So for the machine learning or computer vision, is the LM method, is Levenberger-Marquardt method, or EM method, expected maximization method. Only these both two. Okay, and one more one is gradient descent. It's only 3 ones. But gradient descent is the first order. It's that look like the tether, first order tether. So back to here. So only 3. 2 are nonlinear, and the third one is stochastic gradient descent. I'm sorry, gradient descent. So the gradient descent is not a good method. It's no good compared with LM and the EM because this better. So if you want to have the best optimization result, it's better use the second order optimization because your curve, your loss function is the mean square difference or sum of square difference, is second order. So you try to solve the second order equation, you should use the second order optimization. Okay, but for the LM and the EM are not easy to solve, very high dimension solution. So our deep learning is very high dimension because we have a lot of parameters, so they are not easy to solve by LM or EM. So we use the first order, use the gradient descent to solve it. So, but before we do the LM or EM, we need to make sure the initial position is very important to solve the solution. So that's why we use either cross-form solution or pseudo-inverse solution to have the initial result. So after you have an initial result, and we apply the second order method to get the final result. Okay, so cross-form solution, pseudo-inverse, and Taylor or gradient descent, or the first order solution. But it's not no good. Okay, so how do you improve that one? We call how can we approximate the first order to the second order， 就是你怎么用一次微分来逼近二次微分。That's iteration. So we need to allow iteration to solve the solution. Okay. And what kind of situation use LM? And what kind of situation use expected maximization? If you want to use LM, that's meaning if you have a ground truth, that's a supervised learning, you use LM. If you don't have a ground truth, that's meaning if you don't have a ground truth, and then you apply expected maximization EM method to solve it. So when you do the sum of square difference or mean of square difference, you have one term is ground truth minus the other term are estimation result. Because your ground truth is supervised, so we use LM. If you don't have a ground truth, it's unsupervised. So don't have a ground truth. How do you do that? You have a 110 minus prediction. So this ground truth, you don't have it. So what you can do is you collect the data, try to find the average value instead of ground truth. So this we use EM method. Okay. So this solution will be LM. And HVD singular value decomposition is factorization. It's factorization 因式分解。So that's first order， 直接解的这样子。好，所以你发现一阶为一阶的就直接解的都是一条式直接解过去了。那二阶就要去微分啊，就比较复杂这样子，逼近嘛。好，那我们再继续。So for your homework, we talk about the AR. So what's the function? What kind of function you will use in the AR? So only have a 3 function. So first one, we need to calibrate the camera. The first one is the camera calibration. To calibrate camera. After, the first one you need to find the chessboard corner, right? You need to dictate the chessboard corner. After you dictate the chessboard corner, that's meaning you have a 2D image solution. So you have a 3D original chessboard information. You got a 2D corner, and then you can start to use camera calibration. So the second one. So after you calibrate the camera, you have a extrinsic parameters. You have intrinsic parameters. So you can do the AR thing. However, because when you see in the image you want to display is 2D. So you need to do the projection point. That's meaning you have a 3D model for the AR, but what you can see is 2D. So based on 3D model, you need to project to 2D. So you need to use project points. So the answer will be 5, 1, 3. 5, 1, 3 for the answer. Okay. And the question 3 is SIFT. So SIFT, I just ask you the order, this one. So what is this one? 1, 2, 3, 4. So actually I already give you the answer. What's the answer? First of all, this one we call key point of correlation. So it's just, the second answer is a key point. Key point of correlation. 这些答案我都跟你讲了，说实在的。所以 the second, so we start from first one. First one we have a downsampling. So it's spatial domain. So the first one solution is this one, scale space. Scale is meaning scaling. The downsampling scaling. So scale space. And we want to extract the corner, the local maxima. So it's extrema detection. It's corner detection. So the first one. So answer 3. The second one is see, there are many corners. We want to find the major corner. So the major corner is local maxima. So this one, local maxima. So the second one, each local maxima we call key point. So be key point of correlation. So the second one. Remember this one, important one is what? Important one is I teach you how to do the subpixel accuracy. 就这里我教你的技巧很重要，是怎么做 subpixel 的东西哦，这很重要。subpixel accuracy. And what is third one? So for each key point, we have a small window, the yellow one, and we want to estimate the major orientation, the theta. So the orientation. Okay. So the second answer is a orientation assignment for each key point. Orientation here. So I already tell you the answer here. And the final one is a descriptor. See descriptor here. So the final answer is key point descriptor. So that's the answer. Okay. Descriptor is very, very important. Many deep learning, that you input one image, the result will be descriptor. This two kind of descriptor. One is the entire image become one descriptor. The second one is the entire image. They detect the key point. Each key point is one descriptor. So I output two kind of descriptor. So descriptor is very important. 就是你在做深度学习，事实上已经压缩到后面嘛，那当 sample 到后面这边，那这些目前这几年很多 paper 都把这些都当成变成一个 descriptor， 跟 computer vision 一样。为什么？你空间变小了啊，你本来是一张影像，最后变成只有512维的 descriptor， 但它是有很多那个 map 嘛 ，feature map， 那每个 map 就一个 descriptor， 那这很重要，这是一个趋势啊。那再来 ，the second is because based on the Henshin matrix here, so we have 2 by 2 Henshin matrix, and Henshin matrix is the first derivative and corresponding to eigenvalue. So we have eigenvalue alpha, eigenvalue beta. So that's meaning for each eigenvalue is a variation for that pitch. Variation. So if larger eigenvalue is meaning there are more texture. So if alpha and beta is larger, this one larger, that's meaning there is more texture. If they are small, it's meaning no texture. So B here, B will be flat. Flat is mean no texture. So B will be flat. Okay. And C is because the alpha, beta all are large. It's corner. Corner is a 2 direction. Alpha is 1 direction. Beta the other direction. So 2 in the texture, 2 direction has a larger eigenvalue. That's meaning here is corner. The corner has a directional, 它有方向性的啊，然后它两个方向值都很大。The last one is if only one is bigger, the other is small. Also, this one is meaning direction in one direction. That means edge. Edge is only one direction. So either vertical edge or horizontal edge. So A and D, the answer will be the edge feature. That's not good. Edge is not good for the unique feature. Okay. The 4th one, the CNN. So I ask you, what's the block? We have 3 blocks. First block, second block, third block. So what's the physical meaning for the second block? This one is just for feature extraction, because we input this one. And after we do feature extraction, so 3 layers, and output for classification. So the block 3 are for the classification. Okay, so this is backbone, and this head. This is backbone for extraction, head for classification. And for the backbone for the extraction, the first layer, I say, what's the physical meaning for the first layer and the third layer? So the first layer is for the global, for the detail, because we have a larger image. So we extract the detail feature. Okay, I see there's an edge or corner here. And the layer 3 is for, because we do downsampling, the image becomes smaller. Okay, so we have the same size of filter. So this is for global feature. So the answer for the layer 3 is the global feature extraction. And layer 1 is for local feature. And layer 2 is the median feature. Okay. So that's the answer. And the last one. Okay. So what's the physical meaning for convolution? For convolution. Convolution is for extraction. So it's for feature extraction. Okay. What's the maximum pooling with the stride 2? That's for downsampling here. And activation function is kind of a nonlinear discrimination, right? Exponential term, so it's nonlinear discrimination. Okay, so that's the answer for the midterm. Okay, continue. So we start talk about today's lecture is about LDA. Okay. So LDA, linear discriminator functions. Okay. So when we talk about the GAN, GAN, ChatGPT, the GPT, remember the ChatGPT is for the speaker recognition. That's what they call chat, CHAT, GPT. We do the visual. So we just use GPT. So we still use GPT. GPT is very powerful. So like my lab, we use GPT. We use the GAN, P pre-train, right? And D is what? GPT. Sorry, T transformation. Sorry. Yeah. But for the GAN is two kinds. One is for discrimination, right? The other is generation. So that's discrimination here. GAN, they have a discrimination and the generation. So discrimination is 分类用 for classification. So GAN have a discrimination, and we do the classification. Classification is the same as a discrimination. 就分类用，分类就是一样 discrimination 或是都一样的东西。好，那 for this example, what's this example? I go to the last page over here. So suppose you have a two classes. So like a face, non-face. And how can you classify face and non-face? So for example, suppose this cross dot is a non-face sample. Suppose 2D sample. So if I crop your face, you detect crop your face. So suppose this image is 21 by 21 pixels. That's meaning each sample in the 21 by 21 dimension is 1 point. 就我把你的人脸，假设我认为 if I use a small window is 21 by 21 pixels, that's meaning your space is 21 by 21 dimensions. 你是在21乘21个400多的大纬度空间 400 dimension, only 1 point. Okay, but in this example, suppose it's 2D. Suppose so this non-face and the circle is face. So how can you do the classification for the face and non-face? Or how can you do the discrimination to separate face and non-face? So if I collect the data, so each point is the data I do the collection. Okay, and then this one is face, I do the collection. Okay, usually usually the positive, first we call positive. The sample number for positive compared with the negative sample is at least 1 to 9, 1:9，通常至少 because the foreground is a sample you want to have one image have a face, several face. Most of our region are non-face. So usually the distribution, it is called, all the sample together, it is called distribution. So we have distribution here, we have the other distribution here. And how can you separate both? The important one is that no matter is a face or non-face or any kind of a sample, they have a confused region. They always has a confused region. So it's impossible to separate both 100%. It's impossible. Okay, even though human beings, sometimes we cannot classify correctly. But right now, deep learning is more powerful than the average of the human being for the classification, but they're still confused in between. Okay, so they cause some error. But the same, how can we separate both classes? So the answer is this one. We need to find a line. This is a line here. And we hope this line can separate both clusters. So suppose there is a line. So this equation, but if this 2D, if more than 3D, we call hyperplane, is a plane. 2D is a line, 3D is a plane. But usually we have more than 3D. Like example, I just say it's 21 by 21 pixels. So how can you find, we call hyperplane to separate both classes? So in 2D example this way. So how can you find this one? That's meaning how can you find a line? So back to here. So a line equation is this one. So it's ax ax1 plus bx2 plus constant 2. Constant, this is what the function. A line function 就是第一个你要先知道那个线性，对吧？那个一条线的function嘛。If it's a plane, it'll be ax1 plus bx2 plus cx3 plus constant 10 equal to 0. But this function, if we define the function, we call g. And the parameter, unknown parameter, the sample is x. We have x1, x2, x3. So how can we solve unknown parameters ABC? So the same as deep learning. So all the question we call linear combination problems. So all the linear combination problems, we will change to the homogeneous matrix format. It's meaning AX equal to B problem. 就你要把所有的线性的东西都要转成 AX 等于 B 的 homogeneous matrix 形式。So X is the input, the sample. A is unknown, the parameters you want to solve. And B is the ground truth answer. So here, this equation, S equal to B. So right now I want to let you know the concept. 我一直讲那个观念哈，我不知道你们老师以前怎么教你，高中或是以前线性代数怎么教你们 ？Linear algebra or something. I don't know how professor teach you, but I will teach you is any equation. This one, any equation is a linear combination. Any object in the world, any image in the world, any target, we can use linear combination to approximate that target. So that's a FFT, Fourier transform. Fourier transform result equal to Fourier series. So what's the Fourier series? Fourier series is 不然因为大学会有稍微提到一下这个吧，傅立叶系列手不知道怎么翻，Fourier series。那 Fourier series 是一个 exponential term 嘛？那 what is exponential term? is cosine theta plus I 的 image term 嘛，一个 real domain 一个 image 加上 I 的 sin theta。So all the result, any result, any signal or any image, 我拍照片 image, any voxel, 3D voxel can approximate by linear combination of cosine and the sine. So that's cosine and the sine we call basis function. 叫 basis function. 基本的 function. The same, we just teach you about PCA. Right? So we from the cosine and the sine. After we do the singular value decomposition, we transfer the other to the other domain, eigenspace. So what is the basis function in eigenspace? It's eigenvector. Eigenvector. So in our real world here, our basis function is a sine and cosine. That's signal. Cosine is a Gaussian distribution. Sine is a Gaussian distribution, shift phase 90 degree. Okay, that's in this space, in this domain. And we transfer to the eigenspace, and your basis function is the eigenvector. So with PCA just teach you any phase, all our phase, all the data we collect together and become a matrix and become a covariance matrix. After singular value decomposition become eigenvector times eigenvalue times the other times rotation matrix, 3 terms. So each eigenvector we call eigenphase if it's a phase. So we just teach you PCA. So what's the purpose for the PCA? So for the exam, the final exam, I will ask you this kind of question. First of all, for the eigen, right? For the eigen things, you should understand what's the eigen. And eigen actually is a Gaussian distribution. Why? Because they have a what? They have a standard. They have a eigenvalue. They have a mean. Okay, we back to here. So back to here is so here our sample is X. So what I try to let you know is that even the linear combination here, but in the computer, we do the coding. We cannot write the equation. We should write the homogeneous matrix format. But here, I would like to let you understand the other term is that any linear combination can represent by inner product of this input. This is the parameter that you want to solve. So this AX equal to 0. If they have a constant, is AX equal to B. So the same. X is input, A is the parameters. So suppose for only one equation 就一个式子的话，我们是线性组嘛 ，AX1 plus BX2 plus constant term. So what's the constant term meaning of the physical meaning? 你的 equation 的常数项物理意义是什么？是 translation shift 嘛，对不对？我教你那个 affine transform 嘛，常数项是 shift 空间中的移动。那 W1 and W2 就是 A1 and B，what's that? Scaling rotation， 就这样啊。所以任何的 equation 的物理意义就是 affine transform、scaling、rotation 是前面这个系数，常数项是位移。好，那我为什么讲这个？就这个。So suppose we have a line here， 这个这样画不好，我画不好。这个假设这个线不应当过零啊，应当这个才是过零的线。 我要讲的意思是说，你看这个，我们先讲，假设这是没有常数项 ，if the constant term is zero, that's meaning this line will pass through the origin, right？ 这条线会通过零这一点，如果是零。But if they have a constant term, this line will shift， 这条线会沿着什么地方走？假设这是一条直线，那如果它的常数项不等于零的话，它会沿着哪个方向走？答案是they will go along W1 and W2 because W1 W2 will be what? So that W1 W2 will be this normal direction of this line. W1 W2 the parameters will be the normal direction of this line. If this is a plane, this W1 W2 W3 will be the normal direction of this plane. So that's meaning if I don't change W1, W2 of W3, I only have a constant term. That means this line will shift along the normal direction. That's important. The second is your normal direction should pass through the zero. So you have one line here, right? Even the line L, that's meaning you have the other virtual line here. There's normal direction. 就是说你每一条线上它都有一个虚的线，这条虚的线你看不到，这是它你的 normal direction。那 normal direction 一定通过零。一样，你的 plane， 你的一个 plane，your normal direction 就是 normal 的，一定通过你的零的地方，就坐标零的地方。那是第一个要跟你传递讯息。The first one is that the normal direction will pass through the 0, 0 origin. This virtual line. However, the L will affect and can be affected by the shift translation. So the L, if you have a constant term, they'll shift along the normal direction. This first one I want to let you know. The second is so the normal direction will include rotation scaling. So suppose we don't have a scaling, they fix the scaling. So this one, W1, W2, actually will be cosine theta and sine theta. W1 is cosine theta, affine transform. W2 is sine theta. So that's meaning this W can rotate. So it will be this way. So this L here, and this W. Okay, so L is along you do the translation along this one. Okay, 那我们举例就是假设这个离开这里 ，so suppose we have a L here。因为我这里不晓得用什么线画 ，PDF 档不会画，就 suppose you have a L move to here. So what's the distance? What's the distance between origin and the L? 你就想这个问题。If L is a translation somewhere, like suppose here, and the distance between 0 to the L, so that level equation 那个国中高中的东西嘛，对不对？所以因为你的分母 term 就是你的 normalization term 嘛，那你的分子 term 就是把00带进去，就这样子啊，就变成 d 嘛。所以你的 distance d should normalize by the parameters w1 squared times plus w2 squared and square root， 对，你的实际的距离 ，any point to the L。I'm sorry, not anyway. The origin point to the L will be you will 0, 0 put into and constant term divided by square root of W1 square times W2 square normalization 嘛，单位向量嘛，这没问题。那你要这是距离的问题。那 second one 我跟你讲 W1 W2 是控制它的旋转，就这条线在这里，它是控制它旋转。就是说，我要讲一遍，这条线是 W， 那 W 旋转，这个 L 就跟着旋转，因为垂直嘛，法向的垂直，所以 W 我 pass through the origin，W 已经通过零点，那 W 旋转，就你 L 旋转就 W 跟着旋转。那这个目的要讲多啰嗦讲这么一大堆，是要跟你讲这个，要跟你讲这个。因为这我不想什么，我这里没有这个 PDF 的怎么画，这没办法。就是说，你要想 ，the purpose I want to find a line here to separate both. So actually, the answer is this one. If those points project on the W plane, let's project on the W plane. So they have a two Gaussian distribution here. So the Gaussian distribution is original is a high dimension in the space, right? So the purpose I want to find the line here or the plane here. So how can I find the best plane to separate both planes? Is meaning if any point project on the W plane, and they have a two Gaussian distribution here. So if the Gaussian distribution, the overlap is bigger, that's not a good answer. We hope the two Gaussian distribution, the overlap region is small as possible. That's our final answer. So that's LDA. So the concept for LDA is this one. In the high dimension space, if I project to the other only lower dimension space is W, and they have become Gaussian distribution. And the Gaussian distribution, I hope the overlap region as small as possible. So that's LDA. 这样子，想象到。好，那我下堂课继续讲，就你把高纬度要 project 到这 W， 不是 project 到 L，L 是要把两个区域分开的线。那因为 W 控制 L， 所以你反而是投影到 W 的线，让这两个区域分开，越分开越好，就 overlap 越小越好。那这个就是有名的 LDA。那很多人脸辨识，包括以前公司的人脸辨识用 LDA 来做。So the final one is this one. We apply for the face recognition in computer vision. Most people use two methods. One method is LDA. The second method is a supportive vector machine. LDA, we use LDA. Before LDA, we will use PCA. So PCA is from high dimension. We reduce the high dimension space to the lower dimension. In the lower dimension, we apply to the LDA. And then we'll reduce a little bit, probably only one dimension. 就 LDA 你做完，在 LDA 这个 space 通常是再减少一个 dimension， 就到 W 的这个空间里面去做分类动作。So for this classification is in lower dimension space for classification. So one answer. The second approach is use SVM, supportive vector machine. That's kernel function. Let's project to the very higher dimension and do the linear discrimination. Only two answers for face recognition. If you use the machine learning, one is PCA plus LDA in lower dimension. The second is a SVM. Is a you project a very high dimension for the classification. That's kernel function. So only two answers. Which one is better? They compete. 没有哪一个比较好，这两个都好，都有人在做，结果都很好。那 SVM 的缺点是什么 ？slow， 那个 SVM is slow，LDA is fast，very fast。因为 kernel function 就 slow。好 ，so next hour I will continue teaching, finish this one. Okay, we take a break. Sorry.